ahead and get started. We welcome our audience for our annual Evening With fundraising program for the Dallas Bar Foundation, which this year is virtual. And we want to begin the program by having Evelyn Pulliam, who's the Assistant General Counsel for Toyota Financial Services. Toyota is one of our very generous sponsors, in fact, our lead sponsor, and they've done this for the last few years. So we very much appreciate their generosity. All the money that's raised from this program goes to provide scholarships for minority law students at North Texas Law School. So Evelyn, welcome. Thanks you for being with us and for your sponsorship.
Thank you, Talmadge. It's a pleasure to be here today on behalf of Toyota Financial Services and Toyota Motor North America as presenting sponsors of this event. We're delighted to support the Sarah T. Hughes scholarships because Toyota recognizes the valuable contributions the scholarship recipients make to the Dallas legal community. Toyota realizes the importance of diversity and inclusion in the legal community, and that a business like Toyota can only succeed if we understand the unique needs and perspectives of all our customers. We do that by ensuring we have a diverse workforce where everyone feels free to be their authentic selves. Diverse thoughts and backgrounds make us a stronger organization. That value proposition carries over into the expectations we have of our service providers, including the law firms we engage. Having diverse legal representation is a crucial component to our strategy. We seek to engage minority-owned law firms as well as minority timekeepers and majority-owned law firms. The Sarah T. Hughes scholarships serve a vital role in helping us achieve those objectives by maintaining a pipeline of high-caliber minority legal professionals. Thank you, Dallas Bar Foundation, for honoring the memory of Judge Hughes with this impactful scholarship program. Personally, I'm thrilled to attend today and have the opportunity to hear from such an illustrious author as Mr. Isaacson. We're certainly grateful to him for being here and for all the individuals and organizations who put this wonderful event together. Thank you all for joining us in our support of the Sarah T. Hughes scholarships.
Thank you, Evelyn. Thank you, Toyota. We hope that you and all your people enjoy the program again and want to sponsor next year. But it's my honor now, as the chairman of this year's Dallas Bar Foundation, to introduce our keynoter, the person why you're all here, Walter Isaacson. Walter, as I was thinking about an appropriate introduction for you, I thought of the Dos Equis commercial, the most interesting man in the world. Walter is...
hey, wait, Talmadge. Let me say, you're the most interesting person. You're so wonderful putting it together. And I will reveal, only because it's you, my dirty little secret, which is if you write about really interesting other people, then they think I'm interesting. Not really. I just write about interesting people.
Well, you do more than that. Walter, as most of you know, was the managing editor at Time Magazine. He was the head of CNN. He was the head of the Aspen Institute. Every book he turns out becomes a #1 bestseller. He's a professor of history at Tulane. He's got the most impressive resume of anyone I know, and he's been smart enough to stay out of politics. So we're glad to have Walter today. Our timing actually could not be better. We thought we were going to have Walter in person last fall for our annual fundraiser. And of course, that got canceled because of the pandemic. So when we decided to go virtual, and Walter was nice enough to agree to go virtual, it happened to coincide with the release of his current bestseller, The Code Breaker, which has been #1 for pretty much ever since it came out. It's still right up close to the top. It's an amazing story. And so that's what we're going to be talking about today. And we've had a little VIP reception. We want to thank our very generous sponsors. In fact, we're going to end up making more money off of this virtual program for the benefit of the Sarah T. Hughes Scholars, because we don't have food costs or wine costs or venue costs or all those things. And fortunately, our sponsors for providing the funds got many copies of Walter's new books. And so we hope those get distributed around and people read it and tell their friends so we can keep the momentum going. Walter, let's start with kind of a transition question to kind of understand kind of where you are now compared to where you used to be. You began your career as a biographer, writing about American statesmen who weren't presidents, people like Atchison, Kennan, Kissinger. But then your next biography was of a statesman, Ben Franklin, who was also an inventor. And ever since Ben Franklin, you've moved away from statesmen and you focused your books on people who made their mark on history through their innovations. Da Vinci, Einstein, Jobs, and now Jennifer Doudna. So what inspired your shift from writing about statesmen to writing about innovators?
It's a really good question. And thank you, Talmadge, for actually remembering all the stuff I've done on a long career. But after a while, I had written about diplomacy, and it seemed to me that Benjamin Franklin was the greatest diplomat we've ever had in America. He got France in on our side in the Revolutionary War. He did the balance of power between France and the rest of the Bourbon Pact nations versus England, so that we got Spain and the Netherlands. He understood realism in foreign policy, but he also understood idealism, that our ideals as a nation were going to be what influenced other countries to support us. So he printed the Declaration of Independence when he gets to Paris, that type of thing. And so I began to see that with Benjamin Franklin, he wasn't just a diplomat, but he was a scientist. He understood balances of power. He understood checks and balances and Newtonian mechanics. But he also loved the humanity. He loved the power of words. He was a printer. He was a writer. He also loved art. He made musical instruments. He invented things. And I began to realize that people who are good in a variety of fields, who don't just silo themselves, who aren't just, specialists in one particular thing, but see patterns that go across nature, those are the people who can be very creative. Benjamin Franklin was interested in everything. When he goes over to Europe, the 4 or 5 times he makes that trip, he's always measuring the temperature of the water so he's the first to chart the Gulf Stream. He figures out how storms move by measuring them during lunar eclipses. All these wonderful scientific things, but that look for evidence, it made him a good politician, because unlike some of our politicians today, he was always somebody with an open mind who said, well, let me look at the evidence. Let me do the experiment. So that led me on a quest to always be writing about people who were curious, had open minds, and who loved the beauty of nature in all of its manifestations, from math to music, from art to anatomy. And of course, Leonardo da Vinci is the ultimate of that. But so was Steve Jobs in our day and generation. And yes, Einstein, when he's struggling with relativity, pulls out his violin and plays Mozart because it connects him to the harmonies of the spheres. So I like people like Leonardo da Vinci, Ben Franklin, Jennifer Doudna, Steve Jobs, who love the beauty of the patterns that exist through all disciplines.
Well, I'm happy to tell our audience, Walter and I really first met by being involved with Ken Burns, the documentary filmmaker. And because of Walter's book that I think kind of opened up the intellectual horizon about Ben Franklin, that Ken is now working on a documentary about Ben Franklin, where I'm sure Walter will be the premier talking head on that documentary. So a couple of years down the road, hopefully we'll be
I think we're going to get it by the end of this year. I've seen a rough cut of it.
Oh, I'm glad to hear that. All right, but we really today, now that we know how you decided to write about innovators, we're going to talk about a cutting edge innovator, today's innovator, Jennifer Doudna, your new book, The Code Breaker. And Walter, keep in mind that our audience today is almost entirely lawyers. And so probably most of the people had never heard the acronym CRISPR before, which is obviously a central theme here. It's the acronym Clustered, Regularly Interspaced, Palindromic Repeats. So to help our audience to know what we're going to be talking about this afternoon, what is CRISPR?
Well, first of all, it's a subject of the great intellectual property battle of our time, a 5-year patent dispute over exactly how obvious each step was and who made it. And don't worry about that very long acronym that only you seem to be able to remember what it stands for. It was coined by a Spanish graduate student who discovered these clustered repeats, and he wanted a fancy name for it. So he said, I'm going to call them CRISPR. And then he had to reverse engineer it. So he got all the letters right, except for the E. So it's CRISPR without an E. And what it is this graduate student in the 1990s saw these clustered repeats. And then he and a group of people who worked for a yogurt company and a lot of scientists figured out it was the way that bacteria fight viruses. Now, you think we got problems with viruses? For more than 1 billion years, it's been a life and death struggle between bacteria and viruses. And so what bacteria do is they take a mugshot of any virus that attacks them and puts a little snippet of that genetic code into these clustered repeated sequences so that if the bacteria gets attacked again by the virus, it knows how to recognize the virus and it cuts it up with a pair of scissors called an enzyme. So that's all it is. But what Jennifer Doudna and her research partner Emmanuel Charpentier discovered in 2012 is we can re-engineer this system so that we can recode the guide. So it doesn't just cut the bacteria of a virus, it'll cut it won't just cut the genetic code of a virus, it'll cut our genetic code. It'll be able to make gene edits in humans. And this becomes an incredibly important tool. It's helped us in our own fight against viruses, and it helps us cure genetic diseases. It helps us fight cancer, and someday it might help us design our babies so our babies have certain traits that we may want. So gene editing is going to be the technology of the 21st century that's going to have the most promise and to some extent the most peril. And the name we use for it is CRISPR.
Mm-hmm. Now, with that explanation of what CRISPR is and how it can be used as a gene editing tool, and again, we're thinking as lawyers, not as scientists, the question is, how difficult is it to use CRISPR to edit genes? Is this something you have to be a PhD to be able to do?
No, in fact, there's a person near Dallas who has a shop online called theodin.com, and he's a biohacker, and he'll sell you the CRISPR materials that you need so that you can edit human cells, you can edit genes. I did it myself. I don't have a PhD in biology, but I went to Jennifer's lab, and as you know, Talmadge has a whole chapter in the book and even my author's photo, and the chapter's called I Learned to Edit. So it's going to be easy to edit genes. What is difficult and what you need doctors and fertility clinics to do is to deliver into human cells the edited genes you've made. And so that means the genes or the genie won't get out of the bottle quite as easily. When I did mine, we just flushed them down the drain with chlorine so they didn't enter the population. But what doctors will be able to do in the future is they'll have to find delivery mechanisms. For example, a woman named Victoria Gray last year became the first person to be cured of sickle cell using CRISPR. The hard part wasn't editing her stem cells in order to make sure she made better blood cells that weren't sickled. It was taking out the stem cells and then retransplanting them into the body. That's what's costly. But eventually, we'll be able to do things in an easier way. So this is a technology that's going to be pretty widespread, which is why we have to figure out how do we want to use it.
Mm-hmm. Now, the book is all about what's happened in science to develop our knowledge of CRISPR and use CRISPR for gene editing. But it's also, as you said in our earlier segment, it's a story. It's a story of people and their advancement. And obviously the leading character is Jennifer Doudna, who grew up in Hawaii. And your book, like all good biographies, gives a good account of kind of what happened during her growing up years that shaped her toward this amazing career that she's had. So many of the people in our audience have children, and they surely want their kids to grow up and develop their full potential. So give us your assessment of how Jennifer Doudna's father inspired her along the way to become a scientist.
When Jennifer was in middle school, her dad left on her bed a paperback called The Double Helix by James Watson. And Jennifer, young girl then, thought it was a detective story because she loved detective stories and her dad used to bring them home. And when she read it on a rainy weekend, she realized that in some ways she was actually right. It was a detective story. It was about searching out the clues to the secret of life. It was a story about how James Watson and Francis Crick discovered the structure of DNA and how it works. And one of the things that struck Jennifer was, oh, wow, life is a wonderful mystery, but we can discover clues and figure out how it works. Another thing she discovered was that there was a character in the book named Rosalind Franklin who did the imaging work that helped Watson and Crick make that discovery. And so she told her father, wow, girls can be scientists. I didn't know that. But when she went to her school guidance counselor and said she wanted to become a scientist, the guidance counselor said, no, 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 girls don't become scientists. Well, Jennifer took that as a cue that she was going to become a scientist, and she did. But the thing about Martin Doudna, her dad, and I think this is a lesson for all parents out there, is that he was a literature, professor. He taught, English literature at the University of Hawaii, Ilo. He didn't know much about science, but he didn't just leave the book on the bed. When she became interested in science, he took an interest and he asked her to explain things to him. And even when she's a graduate student and she's doing for RNA what Watson and Crick and Rosalind Franklin did for DNA, she's discovering the structure of RNA and how it was the beginning of life on this planet. Martin Doudna is always there saying, explain that to me, show me your experiments. So we not only have to encourage our kids to have curiosity about nature, but we have to share that curiosity with them. We have to quit saying things like, quit asking so many silly questions. And we should ask, okay, let's figure that out. Why is the sky blue? Why does the sleeping grass curl when you touch it? Why do shells curl the way they do? All these little wonders that you and I were curious about when we were kids, but then we outgrew our wonder years. Parents should know that there's one secret to producing creative kids, and that's curiosity. But the only way to instill curiosity is to be curious yourself.
Now, you've written many prior biographies, but never one before of a woman. And we have people in our audience today who obviously are labor and employment lawyers who deal with gender discrimination and those kinds of issues. And so my question is, was Jennifer Doudna's rise to the top in her field in any way slowed because of her gender?
When she was young, she said she liked playing soccer in a small town in Hilo, Hawaii, so she had to play on the teams with boys sometimes. She said the boys always ran to the ball. Wherever the ball went, all the boys would cluster around it. And she tried to play her position so she'd understand where the ball's going, what the field was like. So when she becomes a graduate student in the 1990s, most of the men doing biology were focused on DNA, the famous molecule, the Human Genome Project. We were going to sequence the human genome and map our DNA. And there are a lot of alpha males doing it, from Craig Ventnor to Eric Lander to Francis Collins. And most of the women, there were very few women involved. So Jennifer focused on RNA, which turned out to be the more interesting molecule. It's the molecule that describes how life began on the planet. It's a molecule, as she discovered, that allows you to make a gene editing tool. It's a molecule, as we found out in the past year and a half, that allows you to make messenger RNA that will build little proteins in our cell that will vaccinate us against coronavirus. And so by not following the ball, but being on her own course with other women who are in my book, like Jillian Banfield and Emmanuel Charpentier, she focused on RNA. Now, nowadays, I don't think, and she says she wasn't hindered by being a woman because we try to celebrate, as I do, the women in science. But what hindered her was when it came to the finance community, when it came to the venture capital community, and sometimes when it came to the intellectual property lawyers, when she was trying to form companies that would use this discovery. The venture capitalists in the room tended to be all men. They suggested men that could run the company for her. And so she says she's not really encountering in the life sciences much gender discrimination. But when it comes especially to venture finance, she said it's still something where women have to break through the ceiling if they're going to run companies of their own.
Now, in our audience with all these lawyers, a lot of them are the head of their law firms, head of the bar associations, leaders in their field. And your book demonstrates what makes Jennifer Doudna such a great leader of her team at Berkeley. So what are her most important leadership traits that we should read about and think about incorporating into our efforts to lead in our fields?
The first team she was on was when she was studying RNA at Harvard. And the leader of the team said, always ask the big questions. And she said, what's the big question here on RNA? And the person said, how did life begin? That's the big question. But then the second lesson is God is in the details. If you're going to figure out how life began, or how you use RNA as a messenger in a vaccine, or how you use it as a guide for a gene editing tool, it depends on tiny little things like the twists and the folds and how it's shaped. And so she understood that collaboration and teamwork meant having a really big goal, but it also meant keeping track of God in the details. She was the type of person who formed teams that were collegial. She always has always interviewed people who want to join her lab or her companies, but made sure the other people in the lab and the companies interviewed them said, do they fit in? Are we going to feel comfortable with them? Now, that was different from Steve Jobs, who was also a great builder of teams. But like Abraham Lincoln and Franklin Roosevelt, he liked creative conflict. He liked teams of rivals. He liked people who would challenge each other. I said to Jennifer, if you're building teams in the collegial way you do it, don't you miss out on people who are going to challenge each other? And she said, different people have different ways of building teams. This one is right for me. I like people who have each other's back, who work together. Other people like building teams where there's more creative tension. So my answer is biographies are not how-to books. They don't say the 2-3 lessons of how to build a team. They say, here's a biography. So you can read Steve Jobs and see that he built a team a certain way. Jennifer did it her own way. You got to look into yourself and say, how am I most comfortable when I build a team?
You mentioned when she was a child how her dad introduced her to the idea, and she recognized it, that this work by Dr. Watson was in fact a great detective story, and that's intriguing. People like detective story. So let's get specific on CRISPR and its use in gene editing. Give us your perspective on why that's such a great detective story.
You know, you had to figure out how do the pieces come together. You had to look for the clues. We knew what CRISPR was doing in bacteria, partly because these yogurt makers were in my book. The biggest problem at Danisco, the world's biggest maker of starter cultures for yogurt and cheese, is that starter cultures are bacteria and they get destroyed by viruses all the time. So they found out clues by looking over the years, how viruses attack their starter cultures, and then how these new CRISPRs were formed in the bacteria because they had year after year of sequencing data. So people, scientists build up clues that way. Jennifer was able to say, what are the essential components? And it came down to 3, 2 little snippets of RNA, which she fused together to become a guide, and 1 enzyme, which is just a simple protein that cuts DNA. And so she pieced together those clues. The patent battle for intellectual property lawyers in your audience is that that was an amazing discovery that had great consequences. How can you put together something that will edit a gene? But her rivals at MIT, led by Fong Zhang, said, well, she did that in a test tube using bacteria cells because she wanted to know the exact chemical components. Those were the clues she looked at. We're going to figure out how to optimize it to work in human cells. And so that was the big race at the end of 2012. Which team can make it work best in human cells? Fong Zhang's team beat Jennifer's by about 2 weeks. They both come up with the answer in January 2013, along with another Harvard team led by George Church. And as an intellectual property lawyer knows, the question then becomes, all right, was that Jennifer's invention and it was just improved in an obvious way? And obviousness has been part of the patent law ever since, I think, the Hopwood case about porcelain versus wood doorknobs in the early 1800s. So was this an obvious step that was taken, or was it a new inventive step? I hate to say there's no easy answer there. This is why for 5 years it's been held up in court. But those are the discoveries that Jennifer and her rivals raced to make in this book.
Now, on the subject of patents, obviously we're talking about intellectual property, we're talking about inventions. You say in your book that, quote, patent law can have a distorting effect on scientific collaboration. How so?
I think both patents and prizes are great things, but taken to an extreme, they can have a distorting effect. Because the instinct of most scientists is to share information, to make discoveries, to publish them as fast as possible, to be collegial. When you get somebody else in a different lab working on something, you say, well, let me show you what we've discovered. And that cooperation, global cooperation, is how CRISPR was developed. It's how the yogurt makers were working with the Spanish graduate student, were working with Jennifer's lab and people in Holland. But when you're competing for patents, of course, you have to be very, very cagey and very, very close to the vest about what discoveries you're making. Likewise, when you're in a race to see who's going to win prizes. Well, Jennifer and Emmanuel ended up winning the Nobel Prize. And when I talked to Fong Zhang, their rival, he said, well, I was really disappointed, but in some ways a burden was lifted. You know, I could now go back to being my more cooperative self. And I think that's going to be true once the patent is settled. But one thing that did happen is Fong Zhang's lab, Jennifer's lab, George Church's lab, they all turned their attention to coronavirus a year ago. And when they did that, they were not asserting patent rights on their discoveries. They were putting them in the public domain as fast as they were making them. And they were saying anybody can build on these discoveries if you're using them to help us fight the coronavirus. So I think it helped right the balance a bit. It helped reduce that distorting effect, but it also helped remind the scientists and perhaps the readers and the young students out there that yes, it's about prizes, and yes, it's about patents, and yes, it's about priority of publication, but it's also about helping humanity. That's why we do this.
In fact, on that subject of the collaboration that responded to the pandemic, you say that COVID became, quote, the biological event catalytic enough to bring science into our daily lives and remind scientists of the nobility of their mission.
So I also want to make sure that readers understand the nobility of their mission. And those of us, including yourself, who got that jab, I think we're pretty much understanding it now.
Well, I think we are, but when this elevation of the nobility among all the leading scientists and their teams and their different laboratories gelled together without selfishness or protectiveness or any of that, were you surprised?
Well, no, because I think that most scientists go into the field not saying, you know, when Jennifer Doudna was in middle school and decided she wanted to become a scientist and discovered the mysteries of life, I don't think she said to herself, and that way I can get a patent and, you know,
get rich.
Become rich. Maybe she thought, maybe I'll win a Nobel Prize. But I think most people go into this field of endeavor just like most of us go into any fields of endeavor, from law to writing to biographies to whatever it is, saying, we want to do something useful. We want to do something that people will respect. We want to do something that'll help our society be a little bit more civil, be a little bit better. And so I think most scientists, that's why they go into the field. But of course, if I'm a journalist, I get caught up trying to get scoops, try to win prizes. And if I'm a scientist, I get caught up in the race to commercialize patents and to form companies. And by the way, those are good things. Competition's a good thing. Forming companies is a really good thing. Having intellectual property is a great thing. It incents discovery. But I think you also have to remember, but that's not the only reason I'm in this game. And that's what COVID helped to remind us, that we're in this game, whether, we're research scientists or writers or all, because we want people to help understand the world and maybe make the world a better place.
Well, let's take that last point to another statement in your book. When you talk about the story of CRISPR, you say it is, quote, an interactive dance among scientists, inventors, and business leaders. Mm-hmm. So how has CRISPR science entered and impacted the business world?
Well, I think soon after Jennifer Doudna, as well as Feng Zhang, make their discoveries, one of their first instincts is to form companies. In fact, when Jennifer, in June 2012, is presenting her paper that's about to be published on CRISPR and how you can use it as a gene editing tool, she was in one of the conference rooms in Berkeley, and 6 people walk in, and none of the researchers know who they are, but they're the patent lawyers and from Berkeley who are saying, okay, we got to make sure we help you patent this. Just like Stanford had patented recombinant DNA in the 1970s. And so what Jennifer does is not only get the patents, but she forms a company called Caribou in order to make therapeutic drugs that will use this CRISPR to cure people. And she forms a company called Intellia to also do things and to do detection technologies so that we can detect not only viruses, but bacteria and cancers using CRISPR. And Feng Zhang creates a company called Sherlock. And what I call it in the book, or what the common phrase is among scientists, is going from bench to bedside. That basically means the lab bench, you discover something, but that's fun to have discovered something, but it only counts when you bring it to the bedside of a patient and you're helping humanity. And that requires not only a pursuit of basic science and making discoveries based on curiosity, it means then turning those discoveries into inventions, like Jennifer did when she made CRISPR into a tool that could edit genes. And then it only helps if you make that tool into a commercial product. And that's what companies do.
Right. The distribution of the genius of the laboratory getting transmitted out into the world. Almost everybody in this audience is a member of a law firm. And an important theme in your book is, quote, science is a team sport. Though as in sports, star players have a big impact on the outcome. So let's talk just about Jennifer Doudna and her team at the Innovative Genomics Institute at UC Berkeley and UC San Francisco. To you, what's the most important, or the most impressive, I should say, component of how they gel as a team?
Well, I think that they tend to come at things from different disciplines. There's a diversity, and needs to be more so, in research scientists, but there are people from around the world, people who are interested in different things, including small organisms or chemistry, and they all come together. Secondly, like I said, is you have to have a purpose, an aim, either the big question, like we're going to figure out how life began, or the big goal, which is we're going to fight coronavirus. Too often, we all get into our silos. It happens at law firms. It happens at universities. It happens with research scientists. They all have their lab. Their silo is figuring out a microorganism or figuring out a chemical reaction. What Jennifer realized when she created IGI and then turned its attention to coronavirus is that we're not in our silos when we all have a project that we have to work together on. And the project of defeating coronavirus required not just chemists and not just biologists, but geneticists and epidemiologists and public health people. And so we had to create teams in which people got out of their silos and worked across disciplines. She said that's done in the business world very well, which is a business leader says, here's the project. People from all of our divisions have to buy into helping on that project. She said it doesn't work in research academia as well because we don't often say, here's the big project. People from different fields have to all work together. That's what she was able to do in the book. When COVID comes along, she uses that as the incentive to say, all right, we're all going to gel.
Now, you've touched on this briefly, but I want to go a little deeper, and that is a key component that drives players on teams and teams to take it to the next level is competition. You say that, quote, competition is the fire that stokes the engine of discovery. So talk about the competition among the CRISPR scientists. You talked about Jennifer Doudna in Berkeley, the Asian fellow Zhang at MIT, and then Church at Harvard. How did the competition among the three of them cause the advancements to occur more rapidly and in greater depth?
Right. Well, competition, as everybody in this room knows, whether I was a young journalist working for Time and competing against Newsweek, or you're advising companies that are competing against others, that causes us to stay up on Saturday and work weekends in order to get something done. And Jennifer did that. She was working with Emmanuel Charpentier and two particular graduate students. They were around the world. And so when it would get late at night in Berkeley, they'd just be waking up in Sweden and Vienna, where the others on the team were, and they'd hand it off and they'd work 24 hours, 7 days a week because they knew they were in a race. So competition spurs us on. And Fong Zhang, who grew up in Des Moines, sweet Midwestern collegiality to him, has all of that sort of instincts of being gracious and cooperative that comes from being raised as in the Midwest. Also had to become competitive, and was so competitive he didn't tell his mentor, George Church, that he was in a race with George Church to figure out how to make this work in human cells. I think in the book that competition gets to be a little bit too intense, and but that was better than not being competitive. So I just think we all learn how competition makes us run faster.
Mm-hmm. Now, you've mentioned something we really need to spend some time on, and that is the moral issues, the ethical issues associated with gene editing. Do you believe that there are instances where gene editing should be mandatory?
That's a very good question, because usually people say there are instances where it should be banned. No, I think we believe in this country, at least, very much in individual freedom. And once you get to mandatory gene editing, let's say you decide that it's going to be mandatory to try to edit out sickle cell anemia or Huntington's disease out of the species. I can't imagine somebody intentionally saying, I want my child to have Huntington's or cystic fibrosis or sickle cell, but we don't want government mandating genetic traits. We saw where that led in the early part of the 20th century. There was eugenics, even in the United States at Cold Spring Harbor, but certainly when it gets to Germany in the 1930s, we, I think, have been inoculated of the dangers of anything mandatory when it comes to making us have healthier genes.
Along that line, Walter, tell the story of Jennifer Doudna's dream.
So Jennifer Doudna, after she invents this technology, has a nightmare. And the nightmare is that somebody wants to learn how to use it. And she goes into a room, and the person looks up, and it's Hitler. And that's when she decides, all right, this is a wonderful tool. It's going to save a lot of lives. It's going to end a lot of suffering for people with genetic defects and flaws. But it could also be misused, as you said, if all of a sudden authoritarian leaders are mandating it. And so she gathers scientists from around the world, but spiritual leaders and politicians, in what has been a 3 or 4 year process to say, when are we comfortable using this? And what lines do we want to pause or maybe not cross ever?
Now, you hear the term and you use it in your book about how it doesn't take a whole lot of imagination with this gene editing that people could have designer babies. You know, pick, I want blonde hair, I want tall, I want larger muscles, what you call a genetic supermarket. And that sounds pretty scary. Do you really think, look in your crystal ball, the next 50 years, that there's a real possibility that American society / FDA / governments could go so far as to permit such a supermarket or prohibit such a supermarket?
Well, yes, I think certainly it's going to be scientifically possible. If you're talking, a few decades, 50 years out, people could go to fertility clinics just like you see in the movie Gattaca, and a little bit similar to, science fiction like Brave New World. And we would have the tools and the ability to enhance our children genetically. And that's why I wrote the book, which is I think we all have to focus on this and say, what would be good about that? And what do we want to, as a society, say we're going to have rules and regulations against? Certainly, we will want the individual families to be able to make choices about severe genetic defects. If you have the possibility that your child has sickle cell anemia or Tay-Sachs disease or cystic fibrosis or Huntington's or whatever, I think we'd all want to say, yes, if that can be edited out, you should be able to have children that aren't, condemned to an early painful death from something like Duchenne muscular dystrophy.
Mm-hmm.
But you talked about mandated government gene editing and eugenics. And I said, that's not going to happen, I don't think. But what you could have is almost a free market eugenics, a libertarian or liberal eugenics, in which people can decide what traits they want to have in their children and go to fertility clinics and get a shopping list in the genetic supermarket. And the rich people could say, I want my kids to be taller. I want them to have more muscle mass. Or I want them to have better memory. Or I want them to have blood cells that carry more oxygen so they can be really great athletes. And then we have to say, do we want a society where that's sort of a genetic supermarket? And it's not going to be free, so we'll have, rich will be buying better genes for their kids if we allow that to happen. And that'll lead not only to more inequality in our society, but it'll encode it. We'll have a genetically elite subspecies like in Brave New World or the movie Gattaca. So these are the things I think we would all say, well, why don't we guard against that? Why don't we say you can cure bad diseases, you can prevent things that will be debilitating or deadly, but we're not going to just allow a free market in fertility clinics where you get to buy enhancements for your children. We're going to try to make sure that that's something that we try to restrain. Maybe, some may argue, I don't preach that in the book, but I do have a lot of case studies, and that's where my head got. But George Church, you mentioned him, he asked me in the book, and I explore his side of it, which is, tell me what's wrong with letting people buy better genes for their kids or making their kids taller or giving them more IQ points. Explain to me why that's a moral problem. So I'm going to let the reader decide, but like the science discovery, the ethical issues, I want to go hand in hand with the reader, with Jennifer Doudna, with George Church, with spiritual leaders, and say, all right, here's a line. Do we want to cross it? And then here's another case study. Do we want to cross that line? And that's why I wrote the book, so we can begin this discussion.
I'm going to now move. We have some questions from the audience, and I want to respect them. Coit Johnston on the subject of the patents. Jennifer Dowden is at the University of California at Berkeley and developing these wonderful inventions, and the patent lawyers come in from the university. Is her contract in heading this UCal Berkeley Genomics Institute that any patents that are invented must be assigned to the university?
The laws and regulations on that have evolved over the years, and they're pretty clear, whether it's at Tulane or Berkeley or University of Texas. There's the Dole-By Act, which is Bob Dole and Birch Bayh many years ago, which says government-funded research. So let's start there. Everything we've talked about begins with some government funding, like on basic science of RNA, whatever it may be. So if the government funds it, to what extent does the government have rights on the intellectual property? And the law determines that, which is the intellectual property can be commercialized by the university where it was done, but the government has certain rights. Then universities have certain arrangements with their research professors. And usually it's just a simple royalty split. And it's often pretty standard. But when it comes to the CRISPR patent we're talking about, it is mainly in the name of the University of California. But Jennifer, as the inventor, gets, depending on whatever she was able to negotiate when she moved to Berkeley from Harvard, 30% or so, or maybe up to 70%. But that's negotiated between the researcher and the university. But there's a pretty standard split. So we don't usually fight over that. Whether it be the graduate students, University of Vienna, one of them is, or Fong Zhang at MIT, or George Church at Harvard. It's a contract you make, and there's pretty standard splits on what happens to the proceeds from a patent that may come from a discovery made at a university, perhaps using government funding initially.
Now, a minute ago, we talked about how competition drives discovery. When you were talking about you don't have to be a PhD to edit genes, you talked about people who are selling this stuff on the internet and who you call rebels, renegade researcher, and you profile Josiah Zahner, who tried to edit his own DNA, and you say rebels push the human race forward. So in the instance of CRISPR and gene editing, what impact have the rebels who aren't at Berkeley, who aren't at Harvard, who aren't at MIT, they're in their garage or wherever they are, how have they pushed it forward?
Well, I was sort of quoting Steve Jobs, whose famous ad in the 1990s was, "Here's to the crazy ones, the misfits, the rebels. They're the ones who push the human race forward," because the people who are crazy enough to think they can change the world are the ones who do. And that was a Steve Jobs philosophy, and it comes out of the computer revolution. Because when you talk about the personal computer you're looking down at right now, that didn't come initially out of DEC computer, or it didn't come out of IBM. It came out of the Homebrew Computer Club in the 1970s, where computer hackers and rebels like Steve Jobs and Bill Gates and Steve Wozniak and Paul Allen and others were attending meetings with other hackers and people in their garages and their garrets and their basements, and they were hacking into Intel microprocessors and creating ways to do personal computers. So that's how the personal computer revolution is pushed forward in the 1970s. Now, it's harder to do that with biohacking, because even though you can do some of it in a garage or whatever, doing experiments on CRISPR editing is a little more complicated than hacking code to make Facebook or make Google or to make even Apple computers. But it is being pushed forward by these biohackers. And I think there's a room for citizen science. I think the priesthood of the people I write about, they're very contemptuous of people like Josiah Zahner, who want to take matters in their own hands. But because perhaps I admired Steve Jobs and admired Wozniak and Bill Gates, I kind of do admire people sometimes take matters into their own hands. And I think we all should have some fingertip feel for citizen science. When Josiah Zahner, the biohacker, sent me a homebrewed vaccine he had made for coronavirus using one of the scientific papers about genetic vaccines, he said, "Here it is, inject it in yourself." Well, look, I may admire the biohackers. There's no way I was going to inject Josiah's into my arms. But I did decide then to sign up for the Pfizer trial. So, almost a year ago, in June or July of last year, I said, all right, I'm going to sign up for some clinical trials because I believe all of us as citizens can get involved in science.
And I think, in fact, our esteemed guest, Judge Barbara Lynn, in the session beforehand talked about, do you prefer to research your subjects or do you prefer to interview people about your subjects? And I think something that intrigued me about the Code Breaker was how you put yourself into the subject, whether it was by doing the gene editing yourself or understanding what these rebels are doing, responding to the vaccine. Do many of your colleagues who write about current events make that a practice? I thought it was a terrific practice because it added a new dimension to your book, but was that a hard decision to put yourself into the real world of this book?
Well, my motto at the school here in New Orleans, where I went, Newman School, was we learn to do by doing. And I think that's an important thing, that if you're going to write about gene editing, you should try to do it. You should be involved. If you're going to write about the ethics of CRISPR, you should be at the conferences, you should be engaged in the discussions. And I think when you're writing a journey of discovery, you want to say, all right, I am going to be with you, the reader, and be with the subjects like Jennifer Doudna and Emmanuel Charpentier and Feng Zhang. And together, we're going to go on this journey of discovery. And I think that sometimes current journalists do that to a fault. They insert themselves into the story way too much. They're giving you their opinions before they've done the research. So I hope I don't do it too much. But when I'm there, as I'm watching something happen, I want to make it feel as immediate as possible. So I talk about being in the room where it happened. I talk about what we all figured out. I talk about the ideas, the things that, when I end the book by the balcony behind me that overlooks Royal Street in the French Quarter here. And I talk about looking at the diversity of people walking below my balcony here in the French Quarter, and how one of the perils of gene editing will be that I love seeing that diversity. People black and white and Creole colored and every hue, and tall and short and fat and skinny and blonde and blue-eyed and brown-eyed and gay and straight and trans. And I say, okay, what's that going to do to the diversity of our species if everybody can edit and try to create the perfect baby? And these are things that, as I think them through, I want to be transparent with the reader. I'm saying, I don't have the answers here, but let's go with me and you and Jennifer and George Church and Feng Zhang, and let's think this through together.
Well, many times, both in this interview and in every article or essay that you've written since the book came out, you keep talking about how complicated these ethical, moral issues are, and how we just need to proceed day by day, hand in hand, which is obviously an admirable goal. On the other hand, you also know how divided our society is today. And the idea that, yes, on the one hand, we're all in this together. On the other hand, people don't want to get vaccines, all kinds of fearful responses. People are afraid to see the future. And so to confront these complex issues, like how much enhancement are you going to permit, which will necessarily promote social inequality, which is not a goal. Is it realistic to think we're ever going to get to a point where there'll be broad societal consensus?
It's going to be difficult to get to a broad societal consensus. because I think the greatest threat that we face as a democracy, as a country, is the divisiveness that has, over the past few decades, increased dramatically. And yes, we used to be divided over how high taxes should be, and those were interesting disputes that were fair and people could understand it. But now we politicize everything. We politicize whether or not you should wear a mask. We politicize whether or not you should get a vaccine. It becomes ideological. Well, the good thing about gene editing is it hasn't yet fallen prey to that. There's not necessarily a Republican or a Democratic position or a liberal or a conservative position on some of these issues. And I wanted to write this book with no ideology at all involved, just a open-minded inquiry into the amazing nature of the science and the difficulty of the question. So we can start wrestling with these questions before our talk radio people or our cable news people start yelling at us and telling us what corner we should be in. And so that's what happens sometimes. We all go to our end of the talk radio dial or our corner of the blogosphere, and suddenly we're working ourselves up so that we're not looking and being open about the questions. We know what our ideological position has been decreed to be. Well, let's not do that on this issue of how we're going to use science for vaccines, how we're going to use science for gene editing. Let's all agree on the basic principles, the most important of which is what type of world do we want to leave for our kids? To what extent is this a matter of individual freedom, and to what extent do we have to look at the good for all of society? We know that that balance between individual freedoms and the good of society and the good of the species in this case is something we have to balance. And different people with different viewpoints are going to balance them somewhat differently. But my goal is to make everybody realize it's a balance. You're not just supposed to go running to one extreme or the other. So if we're going to save our species, if we're going to save ourselves from the dread diseases and pandemics, we have to cure the most important and dangerous disease our society faces politically now, which is a knee-jerk instinct to politicize everything and be ideological about everything, rather than being, as scientists would have us be, as Ben Franklin would have us be, open-minded, looking at the evidence, being curious, listening to other people, finding the common ground. That's what they did when they founded this nation. That's what we did in World War II, and for that matter, when we came out of World War II or the Great Depression. And so I think this is more a book about more than just gene editing. It's about the scientific method, which is before we come to an ideological position, we should look at the evidence, we should have theories, we should test those theories. We should revise the theories if the evidence comes in differently. That was what Ben Franklin, Thomas Jefferson, and George Washington did when they founded this country. And that's what we have to regain by understanding the beauty of nature and of balances and of checks and of how science works.
Well, Walter, our time is up. I know our audience has loved this program. You have exceeded, I think, all of our expectations, certainly mine, in terms of giving us that final thought, in terms of what each of us in our respective worlds has to do if we're going to get back into a mode of being productive and have a society that works better. So everybody, please get this wonderful book. You'll learn a lot, you'll think a lot, and you'll really get to benefit by one of the great thinkers of our time. So Walter, thank you so much. The Dallas Bar Foundation has had an incredibly successful program, and it's because so many people enjoy what you read and what you say. Thank you so much.
And thanks to you, because you were the one who made this happen, Talmadge. It's good talking to you again.
Same here. Well, everybody, thank you so much. Thank all your law firm leaders who voted to spend their money in sponsoring this program, which is how you got your Zoom slots in your books, and encourage them to do the same in their 2022 budgets to support the Sarah T. Hughes scholarships. And have a great day. Thanks a million.